Welcome to EDU World Space.
The problem I will be working on today is this one. Use the arc length formula to find the length of the curve y equals the square root of 2 minus x squared over the interval from 0 to 1. So from 0 to 1, we're finding this arc length.
Here's a clean and
And then we're going
professionally
to check our
formatted
answer by
presentation of the
noticing that this
calculation
is
shown in the image.
part of a circle. And so we're going to solve it just a
Application
little
of
bit
the work
differently.
energy theorem, wet. From the work energy
So when I
theorem, the
start
force
doing
F
a
is given
problem for
by
the
F
first
equals
time,
frac
first
text
if I
KE,
learn
where
a new formula,
KE equals
I
kinetic
write
energy,
down.
S equals stopping
So the
distance.
arc length is
I'm
equal
given
to
for object
integral
A, FA equals
over the
frac
interval a to
100,000,
b,
0.10.
the square root of
For
1
object
plus the
B,
first
FB
derivative
equals frac
squared
225,
dx.
1500 equals
I write it down so that I
0.15
become
text
familiar
makes
with it.
and force ratio
So
frac
I need the first
FA,
derivative. So the first
FB
derivative of our
equal frac
function
0.10,
is going to be 1
0.15
half
equal frac 2
times
null
2 minus
result.
x squared to the
A
negative 1
box
half
frac FA,
times
FB.
negative 2x.
Would you like a PDF
Don't forget the
version
negative
of
2x
this
from the chain
explanation?
rule. And so you've got this as your first derivative. I don't need to simplify just yet. We're just going to hang on to that one. Okay, now that we found the first derivative, we're going to substitute that into our formula here. There's my first derivative, and we're going to square it. And we're going to go from 0 to 1. Remember, they wanted to know the arc length from 0 to 1. So I simplified this a little bit. I squared it, and I got from 0 to 1, square root of 1 plus x squared over 2 minus x squared. Then I took the integral of that, and I got that it was root 2 pi over 4, which is equal to 1.107. Now, if we look at it a different way, this circle here has a radius of the square root of 2, because it comes from the formula x squared equals 2, so the radius would be square root of 2. So if we're looking at this, we know our radius is the square root of 2, and from 0 to 1, that's only 1/8 of the circle. And I know this doesn't quite look like a circle. That's because I took it out of Desmos, so it looks a little eggy, but trust me, it's a circle. So from 0 to 1, that's only 1/8 of the circle. And arc length is just the circumference. So our circumference is 2 times pi times the radius, and then times 1/8. I know that doesn't look like an 8, promise you it is. 1/8, because it's only 1/8 of the circle. When we simplify it, we get root 2 pi over 4, which is what we got up here. So that was awesome.